All right, so what we're going to focus in on today are what we call periodic properties. These are the properties of elements, and this has everything to do with electron configuration. The property of elements that repeat themselves as we go up and down the periodic table. So what are periodic properties? Periodic properties are properties of elements that repeat themselves as you go down or across the periodic chart. For example, as you go down a column on the metal side, the metals tend to become more and more terrifying. I will show you a video eventually that it's from Brainiac. It's an English film that shows you what happens when you add the alkali metals to water step by step until you get to cesium. Oh yeah. It's violent. As you go up the non-metals, for example, astatine is something that you can hold in your hands. You probably don't want to eat any of it, but you can hold in your hands. Iodine, if you hold it in your hands, it'll start reacting with your hands. Bromine is a liquid. If you get it on your hands, it will burn your hands really bad. Chlorine is a gas. If you get it in you, you could probably die. Fluorine is a gas. If you breathe a small amount of it, you will die. So there are some definite patterns to this. As you go down on the metallic side, the metals become more and more terrifying. As you go up on the non-metal side, they become more and more terrifying. It's a predictable pattern. It's a repeatable pattern. All right, here are some periodic properties that we're going to look at. Ionization energy, electronegativity, atomic radius, and ionic radius. Today we're going to focus in on atomic radius. Atomic radius is the distance between the nucleus and the outermost electron. Yes. The distance between the nucleus and the outermost electron. Now, does anyone have a question for me? Somebody in first period asked me an awesome question.
What's the question?
No one has a question. Let me repeat. Atomic radius is the distance between the nucleus and the outermost electron. There you go. If you can't even tell where electrons are, if you're not even sure that electrons exist, how do you know where the outermost electron is? We can actually take pictures of atoms using scanning, tunneling, electron microscopes. They give us 3D bumps to represent the atoms. So what they do is they measure the distance between the bump peaks, and then they just cut it in half. So you're right. The assumption is that the electron clouds, their edges are close to each other. So what they do is they measure the distance between the two nuclei and assume that in the middle, right in the middle, you're going to find where their electron shells are close to each other. It's an estimate. It's not exact. Okay, so here's a video that shows you what happens as you go from left to right, and then I'm going to explain it to you. So, atomic radius is the distance between the nucleus and the outermost electron. Down group 1, what happens? Well, lithium only has 2 floors, right? Sodium has 3 floors, so you would expect the sodium dormitory to be bigger. Potassium, bigger. Rubidium is potassium plus another floor. Cesium is rubidium plus another floor. So as you go down the column, they get bigger. As you go from left to right, check it out. They do get smaller. Why?
Because you need a diversity.
They get smaller, they lose the thing that was inside.
But then it gets big.
So, in review, as you go from left to right, it gets smaller. As you go down, it gets bigger. Now, why is this the case? Okay, so, Spencer,
No, it's good.
Hunter, who is next? Patrick,
Nicole's got a thigh gap, that's how you know.
Asher. Asher, who's next? Then came Emmy. Then came Randy.
Why did it circle?
Then came. Then came.
So far away.
Why? Because she's so little.
They can't see her.
This is depressing.
She's huge. Because she's so little, the electrons are going, ew, gross. Why are we stuck with some skinny, yucky nucleus? Serenity. Do you understand what happens as you go from left to right?
Yeah.
The bigger the nucleus, the smaller the atom.
Smaller. Yeah.
Smaller, yeah, smaller.
Making fun.
The smaller it is.
Are you trying to bring? Hey, that's why I was like you to make your airplane.
No.
Why?
Yeah, we did some hardcore origami lessons.
That's my origami piece.
Actually, illegal papers origami.
Yeah.
What?
This is
Go, go, go.
I'm
Copy
trying.
down.
I don't write that.
All right, so let's look at ionization energy. That's the second periodic property. What is ionization energy? Well, let me help you with a metaphor. Jackson, you're a lineman, right? So if there was to be a fumble and you were to pick up the ball and start running in the opposite direction, you're a defense. Do you ever play defense? Okay, so you pick up the ball, you're running in the opposite direction. How would you run with the ball?
You mean how I run with it like this?
Yeah, how would you run? Would you hold the ball way out here and show everyone, I got a fumble, I got a fumble, or would you hold it close to your body? Hold it close to your body. The harder it is, the closer it is to his body, the harder it is for people like Devon, you know, the fast skinny guys to get the ball away from him. Okay? Fast, skinny, graceful guys who do not pour water all over their front. Okay. So, they teach you guys to, what? Carry the ball high and tight. Right? High and tight. Okay? That's not just in football, it's also in, who plays soccer? Any soccer people here? Okay, you know that you shouldn't kick the ball 5 or 6 feet ahead of you and then run to it and kick it again and then run to it. That's the way they play in little kids. Oh gosh. I remember not playing because we didn't play soccer. When I was a kid, we played baseball. Okay, and soccer was that foreign sport. All right. So, you know that when you're playing soccer, you have to keep the ball close to you or else it'll be taken away. Devon, you play b-ball as well, right? When you're dribbling the ball, do you like to dribble way ahead of you? To have it bouncing back. Dribble, bounce back. No. You know you got to dribble really close. Actually, I was watching some of the freshmen practice, and they kept dribbling between their legs, which I thought was so neat. There's no way I could do that. But they were dribbling between their legs. It's hard to get the ball away when you're dribbling that close to your body. Same principle. Ionization energy is the energy required to rip away the outermost football, or the outermost soccer ball, or the outermost basketball, or the outermost electron from the nucleus. We're talking this one right here, this one, this one, this one, this one. Okay? The outermost electron. What do you guys think? Looking at these pictures, what is the relationship with how far those electrons are from the nucleus and how much ionization energy is going to be required to rip it away? What do you think? Is it going to be easier for Devon to have the ball stripped away from him if he's holding it this far away from his body, or if he's holding it this far? Let's draw here. This far away from his body. Okay, so the principle is actually opposite. The smaller the atom, the higher the ionization energy.
Ionization energy is the energy required to remove an electron from an atom or ion. It measures how strongly an atom holds its electrons. The first ionization energy, I1, is the energy required to remove an electron from a neutral atom. Considerably more energy is required to remove a second electron from the positive ion.
Why? What happens as you lose electrons? What happens to the size of the atom? So, how tightly is it holding on to the electrons? So the more electrons you lose, the tighter you're going to hold on to the other electrons, the higher the ionization energy.
This energy is called the second ionization energy, I2. As each electron is removed by ionization, the remaining electrons experience less electron-electron repulsion and a greater effective nuclear charge. Thus, each successive ionization requires more energy. This graph shows the way in which the ionization energies of the aluminum atom increase as successive electrons are removed. Notice that the
So, look at ionization energy. This is the largest atom. Then they get smaller, 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 smaller. The smallest. What happens to ionization energy? Okay, then we get back here. Large, smaller, 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 smallest. Large, smaller, 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 smallest. So that is a definite trend. The smaller the atom, the higher the ionization energy. So, Atomic radius increases as you go down. Ionization energy increases as you go up. Atomic radius decreases as you go from left to right. Ionization energy will increase. Atomic radius decreases as you go from left to right, up. Ionization energy will increase. Complete and utter opposites. Here is the explanation. All right. What happens to ionization energy as you go down a group? It decreases. What? It's online. All right. Harder to get rid of. It decreases because the atoms are getting bigger, therefore farther away from the nucleus. Therefore harder for the nucleus to hold on to. What? All right, let's look at the third periodic property. The third periodic property is related to ionization energy and atomic radius. It's simply put, electronegativity. Okay? It is how attractive an electron, somebody else's electron, is to somebody else's nucleus. Okay? When I was teaching at West, there was this young feller. Now, don't get down, especially guys should not get down on this young feller, because you know you do the same thing. Guys rate girls. In their minds, at the very least, they rate girls. Devon probably has every girl rated in this room. On a scale of 1 to 10, he's got them all rated. All right? It's just natural. It's what we do. Like, we breathe and we eat and we pass gas. We rate girls. That's what guys do. Now, most guys are smart enough to keep it all, like Devon, in his mind. This feller was idiotic enough to get a notebook and put it down in a notebook. He had virtually all the sophomore girls ranked, not just overall ranked, but he had their features ranked. Not only was he idiotic enough to put it in a notebook, he was idiotic enough to bring the notebook to school. Not only was he idiotic enough to put it in a notebook and bring it to school, he was idiotic enough to leave the notebook under his desk. So I came in to my classroom, and there was 6 or 7 girls all gathered around in a circle, and you could feel the feathers coming off, and there was feathers ruffled, and there was definitely some tension, and I kept hearing, "He did not." That kind of stuff. I go, okay, I better figure out what's going on. So I kind of got through the crowd. I go, let me see that. And they said, and this girl looked at me. She had fury in her face. She red-faced and said, look! And she showed me the notebook. And I started paging through it. And I said, holy cow, they're going to kill him. So I called our female principal, who I knew was going to deal with it. On the side, she was a basketball referee, so I knew she was tough. And she came up and she looked at it. Her eyes got big. She says, I better go save his life. She saved his life by giving him 5 days of out-of-school suspension in order for it all to calm down. Okay, those girls had already rated him in the back of the notebook, Randy, and it wasn't good. Okay? So, that taught me right there to make sure that my sons always know that if you're going to rate girls, you never put it down in a notebook. Believe it or not, in chemistry, we have atom ratings written down. It's called electronegativity. Electronegativity is how attractive a nucleus is to the electron of another atom. In other words, how good looking a nucleus is. Folks, when you get a chance, look at the back of the periodic table because you have the little black book there. The electronegativity chart is there. All the atoms, or at least most of them, are rated from 0 to 4. Now you know, guys, if you want to be romantic, like if you want to have Gracie as a girlfriend, go up to Gracie and go, ooh, Gracie, let me just tell you, sweetheart, you are a perfect 4.0. And say it really kind of low and silky like that. She likes that, right, Gracie? You want to be told by a guy that you're a perfect 4.0, don't you? What if a guy comes up to you and says, oh, Gracie, you remind me of fluorine? And he does that to his eyebrows. So you run to the periodic table, turn it over, because you should have turned it over by now. Turn it over, look up fluorine. No, turn it over, look up fluorine on the electronegativity chart, and notice what number it is. Oh yeah, what did that guy just say that you were? You were a perfect hunk of woman. There you go. Yes, folks, electronegativities are ranked from 0 to 4.0, where 4.0 is considered the most attractive element on the periodic table. Now, if you're really sick and tired of this dude and he has Gracie, this is what you do. You go up to him and say, you disgust me. You are cesium, as far as I'm concerned. Ooh, what did you just say, Gracie? Yes, 0.7. Okay, what does that mean? When, it's ugly. Can't get uglier than 0.7. Okay, he's still a human being, but he's still the ugliest human being that Gracie has ever met. Watch.
An atom attempts to attract electrons toward itself when bonding with another atom. The level of attraction of each atom is called its electronegativity. When sodium and chlorine react, the chlorine atom removes sodium's valence electron and becomes a chloride ion. The less electronegative sodium atom cannot compete for electron.
Look, teeny tiny little nucleus. Okay? Ugly little teeny tiny little nucleus. Look at that one. Whoa, nice fat chunky nucleus. So, if you're the electron around sodium and you get the opportunity, what are you going to do? You're going to skip out. Why? Look at this. Your choices are, this girl is 0.9 out of 4. This girl is 3.0. It's a no-brainer.
and becomes a sodium ion. The attraction between the ions is an ionic bond. When bonding atoms have nearly equal electronegativities, neither can attract.
Okay, so you're this electron, Asher. Here's your girlfriend, 2.5, and here's another girl, 2.5, and she wants you too. So what are you going to do?
Bounce back and forth.
Electrons away from the other.
Watch.
In a carbon-sulfur bond, the electron pair is shared almost equally between the two atoms, resulting in a covalent bond. When hydrogen...
All right, Serenity, since you seem to know what's going on, this is you. This is this guy. He's 2.1. I mean, a little bit better looking than average. And here's this guy, 3.5. This is Matthew McConaughey type person, right? So what are you going to do?
and oxygen react. The more electronegative oxygen atom cannot completely remove the electron from hydrogen. The shared electrons are attracted more to the oxygen than to the hydrogen atom. This unequal sharing is called a polar covalent bond.
So because
Polar bonds have a...
is, as you can see, Serenity is spending more time with Matthew than with Devon, then what happens is, well, I mean, you're not Matthew McConaughey. But you're not. You're better looking than average. I did compliment you, didn't I?
And insult him.
But as you can see, Serenity is spending more time with Matthew than with Devon, so that means this is a polar bond.
Slightly negative and a slightly positive end.
I don't think his wife would appreciate that.
Is he married?
His wife? Oh, that's nice.
Okay, so there you go. So think about, so Serenity, look at these guys. Okay, what would Randy be here? Where would you put Randy? Okay, what about Spencer? Jeff?
Oh.
Oh, Jesus.
I don't think I should answer.
Okay.
Complete the fifth.
So, what happens to electronegativity as you go down a group? Well, what happens to the size? So, as the atom gets bigger, yes, bigger, opposite is, so what happens to electronegativity as these nuclei get bigger and the atom gets smaller?
It gets larger. Do you know that funner is a word?
Yeah.
Funner?
Funner is not a word.
Funner is a
Funner
word.
is a
Look it
word.
up. My dad proved me wrong. And it
So
made me
if
mad.
you are the funnerist one, I mean, is it funnerist?
You are
Funnerist.
No, it's funner to do this rather than this. It's like a comparison word, but
It is more fun.
funner to do this rather than
So what happens to electronegativity as you go down a group, and why? It gets smaller because the nucleus, the electrons are further away. You know, the electrons are closer, right? Get small. Yeah, it gets smaller because the nucleus is further away from the electron. There are more electrons between you and the nucleus. What happens is to electronegativity as you go across a period, and why? It gets larger, nucleus is closer to the outer shell, so it's harder to rip away that outermost electron. It's harder to be attracted to the nucleus too.
Wake up, bud. Wake up.
Good morning. Wow. Oh my God, that's good. No, that's how you.
Are we good?
One of those houses that's all like goofy. Oh, I don't know why it's gonna be perfect.
All right,
No.
we good?
Do you want to keep?
No.
Wait.
Oh, I have to write another one?
Cheese. More
Pay
powder.
attention, Tinkerbell. I'm not thinking
Gel.
about.
Therefore.
I was thinking to go. You're a goat. A goat. Instead of ghost, you know. That's all I get.
All right, here we go. Let's review it all. Atomic radius. Atomic radius is the distance from the nucleus to the outermost electron. What happens to atomic radius as you go from left to right? The nucleus gets bigger, therefore the electron gets smaller. What happens to it as you go down? So really, there are three things. In order to know how to do all these questions, there are three things you need to know. Number one, as you go from left to right, it gets smaller. Number two, as you go down, it gets bigger. And then the third thing you need to know is the word opposite. Opposite. Why? Because the other two are opposite. As the atom gets smaller, the ionization energy gets. As the atom gets bigger, the ionization energy gets. And electronegativity. As the atomic radius gets smaller, the electronegativity gets. And as the atom gets bigger, the electronegativity gets. All right, and so as you go from, make sure you also know what happens as you go from diagonal to. Makes sense.
You recorded all this, right?
I am recording it. Ionic radius. What is ionic radius? Ionic radius is very similar to atomic radius, but where atomic radius refers to an atom, ionic radius refers to an ion. So what we're going to look at is what happens to an atom size when it becomes an ion. And here's the metaphor to help you understand. Serenity. We're going to use, since you seem to have no problems just voicing your opinion, we're going to use you as an example. Okay, so you are dating Matthew McConaughey. You like that, but you know you're not the only girl. Okay. So what would happen to how, and you think he's hot, right? So what would happen to what you would feel about him if you were to find out he went out and got himself another girlfriend?
It would get less.
So you're not as attracted to him.
Yeah, because he's not a
Yeah. Does that make sense to you?
nothing about that I don't know.
Okay. What would happen if Matthew was to come up to you and say, you know, I'm dating other girls, right? I got rid of 2 of them because I feel like you're worth at least 2 other girls. So how would you feel about him now if he got rid of 2 girlfriends after starting to date you? So is he more attracted to you or less?
I think he'd be more.
Yes, because he got rid of 2. All right, if you remember serenity and that illustration, then you can understand what goes on here.
All the electrons in an atom are attracted to...
Okay, so this is serenity. Well, no, this is the other girlfriend. And serenity's in here somewhere.
to the nucleus at the same time that they repel one another. The electron shown, one of the outermost electrons of the atom, is partially shielded, or screened, from the nucleus by the other electrons. At the same time, it partially shields or screens the other valence shell electrons from the nucleus. When this outermost electron is lost...
What happened to Serenity and all the other girlfriends when they found out that one of the girlfriends had left?
Yeah, we got closer.
Why did you get closer?
Because there's more room for love.
You're more attractive to him. You're more attracted to him. Okay, that is the case. Whenever a atom becomes a positive ion, it always gets smaller because the electrons are more attracted to the nucleus.
I get to tell everybody I'm saying.
The partial shielding it provided for the other electrons is lost. As a result, they experience a greater effective nuclear charge, and the cation, or positively charged ion, is smaller than the original atom.
Okay.
When an electron is added to a neutral
Here she is.
atom, it experiences a
Oh, what happened? When another girlfriend came in, did you notice what happened to the size of the atom?
How bigger?
Got bigger. Because how does, this is Serenity over here, what does she feel about Matthew now that he's gained another girlfriend?
Like, yeah, no, no way.
Yeah.
Just fine.
So how does the radius differ between a metal and its positive ion? The positive ion will always be,
Smaller.
Just kidding.
I got what?
okay, if it's a positive ion, it's losing electrons. In our metaphor, it's losing girlfriends, right? So how does she feel about Matthew as he loses girlfriend? In the case of metals, they actually will lose their entire outer shell. So as the outer floor is done away with, all the other electrons are going to be more attracted to it. If you're an atom and you gain electrons, then all the other electrons are going to go, "Oh man, another girlfriend? Really, Matthew? Really? Or were we not good enough for you? What is your problem? Okay, we're not going to get rid of you because you're still Matthew McConaughey, but we don't like you as much." That's what Serenity's thinking. Right? All right.
The only reason I'm saying sure is because I have to.
Thank you, Serenity. It's always good to have a football player, lineman, in class because you can judge how fast you need to go by how fast they're going. Actually, that's not true. Who are the most intelligent? Who have to be the most intelligent players on a football team? The linemen. They may be big, they may look like Neanderthals, but they're Neanderthals, but they are actually extremely intelligent. Most of these players can play different positions. Like they can move him from guard to center or from center to tackle from one play to another, and he has to know all those plays. All right, so let's review. This is sodium. What happens if sodium loses an electron?
It gets smaller. Smaller.
Why? Because it lost a girlfriend, therefore Serenity is more attracted to Matthew. What happens if fluorine gains a girlfriend?
You can go away.
What happens if magnesium
Go home.
loses two girlfriends?
It's very smooth.
Serenity really likes it.
Right? It jumps on that right there.
Yeah.
What happens if oxygen
I don't know what the girls are thinking.
gains two girlfriends?
Don't get
He is not gonna get
What is that doing?
What happens if aluminum loses three girlfriends? What happens if nitrogen gains three girlfriends? So the more girlfriends you gain, usually the bigger the ion. The more girlfriends you lose, typically the smaller the ion. Any questions? Yes?
Who's this guy from Congo? Like,
Yeah, who is that?
I don't know. He's an actor.
can I pull my phone out and do one?
Sure. All right. You have 2 homework assignments. That's okay because I'm going to give you 3 whole nights to get it done. Number 1, you have to answer 3 questions to complete worksheet 2.2. That's questions number 3, 4, and 5. And then look on the bottom of your the random 7 questions. Let's go back. It should be 6 questions. Based on what you know so far, we could start making some decisions about the coin that we need to design for our representative Chuck Fleischman to submit to the U.S. Mint. Our job is to create a coin in order to replace, it needs to be a $half coin, right? Okay, so the questions you need to answer are, for Monday, on a separate sheet of paper, what are the characteristics that are necessary in order to make this coin effective as a $half? Number 1, what physical properties must the coin material have? Let me give you, well, let's see if we can't come up with at least one.
Valuable.
Really? You want it to be bendable?
Yeah.
So that when you get it in your pocket, okay, so you can bend it with your fingers? Okay. What other physical properties do you want it to have? Does it? Well, that's not a physical property. That would be number 3. What chemical properties are required? Okay. Is it corrodable? Does it corrode easily? Reacting with oxygen. How about number 5? Which would make the best primary material? Metal, non-metal, or metalloid? Explain. What factors or desirable coin characteristics did you consider when answering question number 5? All right, so make sure you answer those.
He has a net worth of $75 million.
That